Hi everybody, welcome to this introduction to topic 6 in the IBDP Computer Science syllabus. We're looking at system resources. This video will not cover all of the concepts in topic 6, but it will try to cover enough to get you started. Here we've got a representation of typical system architecture. We've got our secondary memory where we're storing our applications and stuff. We've got our primary memory where processes and applications will be loaded when we want to interact with them. For example, loading your browser into RAM will allow you to play with the browser. We've got our cache memory here, which is another form of primary memory where frequently executed instructions will be stored to even speed up more the fetch, decode, execute cycle. We've got our CPU with the control unit and the ALU. Of course, there are other bits and bobs, the registers, etc. And we may have some input and output devices connected to the system as well. So let's say we switch on our computer and we want to open my browser. When I open my browser, the browser software is loaded into RAM, and it can now start to each of the instructions associated with this application will be fetched, decoded, and executed by the CPU. In order to load my browser into RAM, I need a nice big block of contiguous memory. Just memory where all of the individual blocks of memory sit next to each other in physical space. That's a contiguous block of memory. And if I want to open up Microsoft Word, I need to find another contiguous block of memory, and then I can open up Microsoft Word. I'm going to mess around with Photoshop. Then I'm going to close Photoshop, so Photoshop disappears from RAM. But I want to open up another application, and then close an application, open an application. So lots of things are happening in RAM over time, and eventually things could get a little bit, as we're looking for these contiguous blocks of memory, things get a little bit messy. So I try to load the next application, and unfortunately this time there are no contiguous blocks of memory available, so I cannot load this program into RAM. But if you look closely, there are some gaps here in RAM. I bet you if we could slice this up, we could fit each individual slice in here and get this application loaded into RAM. And that's exactly the idea that computer science came up with to solve this problem. Those slices are known as pages. So let's just clear RAM for a minute and let's look at how these pages might look in RAM. So let's say that I want to open up my application here, and RAM is already quite busy. There are no contiguous blocks of memory, so I'm going to cut this or slice it into pages and fit each page into an area of RAM if I can find it. And if I want to load this application or process, I'm going to slice it up and find into pages and find little blocks of memory where I can store those pages. Okay? So now I'm able to open applications in RAM in non-contiguous blocks of memory by using this pages idea. Of course, the operating system is controlling all of this. And the operating system has to track which little block of memory is related to which page, which is related to which application. So we are making the operating system a little bit busier by adopting this strategy. Now, just to move on, I'm just going to clear some of this out of the window, just to clear things out a little bit. Actually, there is one thing that I wanted to talk about, so let's just put them back. Let's say now that I want to load this application into RAM. Well, there's no space to do it. But let me tell you, some of these processes are idle, and they've been idle for some time. So what the computer operating system is going to do, sorry, I'm just messing around with Illustrator here, it's going to identify any of the idle processes or processes that haven't been used recently, and it's going to store them in secondary memory. Okay? So it's going to say, okay, you guys, we're not using you at the moment, you're idle, we're going to put you into secondary memory, and if we need you later, we'll ask you to come back. This process that wants to be loaded, this process here that wants to be loaded, is cut up into pages and then loaded into any of the new available slots. So using secondary memory space to simulate RAM is known as virtual memory. Virtual memory generally is used to store idle pages existing in RAM, and if we need them to return to RAM, we can free up some more space by looking at more idle pages, swapping them into virtual memory, and then pushing back any processes that need to be active again. Okay, so that's a very brief introduction to the idea of pages, contiguous and non-contiguous memory.